Okay, welcome back. In this section, what we want to do is show how to write a program that will do basic math operations, addition, multiplication, sine, cos, all the kinds of things you would do on your calculator, and display those results in a UART, input-output window. So we're going to create a new project. We're going to find the 2620 chip. We will use the simulator, XC8, and we're going to call it Math. And let's finish. Okay. Now, what I'm going to do is I've already created a file. So I'm just going to drop it in here. mathmain.c. And I'm going to come to source files. And instead of creating a file, I'm just going to add this existing file, mathmain.c. And let's have a look at it. And here's the code. And here you can see I'm doing some addition, subtraction, multiplication, division, and modulo. Right? Modulo gives you the remainder, like 5 divided by 2 goes in twice with 1 left over, so this should be reply 1, leave 1. So that's it. I have a main, I've got a return. Let's build this, see if there's any problems. Oh yeah, there are problems. And the problems is that it says it has unidentified identifiers A, B, C, and D. And that's the first thing. Our function, our variable names A, B, C, D, we have to create space for them in memory. And we do that by creating these variables and defining the type. We're going to make them integer variables. End with a semicolon. And this is our variables. If I wanted, I could even give the variables an initial value, like making e equals 10 or a equals 0. Doesn't really matter if I do that. So all I've done is in computer memory, created this spaces called A, B, C, D, and E, and made them available for us to do calculations. Let's clean and build, see what happens. A, success. We've done it. We've done the first set of math operations. So we have this project where we can do basic math operations, but we're not yet able to see the results. To see results, we make use of a function called printf. This function is in a library called the standard input-output library. And it's a library that comes with C, and it's standard. So right here, the chevron brackets say that this is a C library. We don't have to add anything else. It knows where its own libraries are. Okay. And the way this function works in here is you create a string, a double quotes here, and you tell it how you want it to present data, and you use things like this right here, a percent sign followed by a U that says print an integer that's a positive number. So percent U, percent U, percent U, percent U, and percent U. And over after that string, we just put the name of the variables, A, B, C, D, and E. And each of these percent U's will take the number of the value of A, B, C, and D, and turn it into a number that it prints out. Now, this would work if you were programming in C, but it's not going to work for our picks, because our picks, you have to tell your computer chip to print things out. It has something called a USART module for printing. And to get that to work, we've written some code for you. And there's a function called configure USART that does that for you, configure USART. There's a couple of settings to tell it that we want to communicate at 9600 bits per second. UL just means unsigned long. And we want to do it at 1 megahertz. 1 megahertz is the basic speed for our, or default speed. And this is in a library that we put in the functions directory. So I'm typing the name, configure USART.h, and over here I have to add that item. Here it is, configure.c, and I have need the header as well. Configure USART.h. And that's it. We need to do a few things about the project. In the simulator, we want to make sure we're working at 1 megahertz, or simulating 1 megahertz, because I said this is at 1 megahertz. And in the UART module, we want to make sure that when it prints to a UART window that's been simulated here. And so that's that. And in the linker, that's not super important here, but the memory model, 32 bits for doubles and floats. So let's say OK. And now we're going to build this. See if we have any mistakes. It said the build was successful, so that seems good. And now we run the program. So debug the project. And it's going to create. And here's this window. And holy, look at that. It's printing out the answers, but it's doing it over and over and over again. So I'm going to come up here and stop this. Come back to Math Main. The reason that's happening is programs written for the pick, when they finish, they restart again and run over and over again. So what we want to do is add a while one statement. And this is do forever. So when this is built and it runs down through here, it'll stop at the while one, which just means wait forever. Here we are in the UART window. Let's clear the window and let's debug the project again. Okay, that worked. And here we are. Those are the results. And let's stop this. Doesn't need to run forever. And A is 7, B is 3, C is 10, 5 divided by 2 is 2. When you D is an integer, right? So it can't give you 2.5. It's going to round down or floor it down to the nearest integer, and the remainder of 5 modulo 2 is 1. So one last thing. We've been using integers, and we saw how D equals 5 over 2 gave me a result of D equals 2. How would we fix that? Well, we made this an integer, and that's just the typical behavior of integers. So let's get rid of D here, and let's make it a decimal number. So you can either write float or double here. Okay, so now D is a float, And D would be this guy here. This is for integers, so if you want a float, it should be a %f. And let's see what that does for us. Let's debug the main project again. Successful. Let's go to the window. And here we go again. 3, 7, 3, 10, 2.0. Hold on. 5 divided by 2. It's supposed to be 2.5. That's true, but it's not how C works. Right? When C sees a number, 5 divided by 2, 5 is an integer, 2 is an integer, and you're dividing them, it assumes you want an integer result. There's a couple of different ways to fix that, but this is a common source of errors when people are doing math with integers in C. So one way to fix it is simply say 5 decimal or 5.0, and now it's no longer an integer divided by an integer. Okay, so let's stop this and debug the project again. Go to this, and now you can see that it's giving me the correct answer. And the second way we could have fixed this is if I use what's called a cast, where it says, see this number 5? Treat it as if it's a float. So I should stop that. Go to debug the main project again. And again, it gives me 2.500. Perfect. So remember, dividing an integer by an integer is not a good idea in C. It always is like a floor operation, even if the result is supposed to be a float. So you have to be careful about things like that. Thanks for now.